Hello, welcome to week 10 of CSM. In this video, we're going to be covering all of question 2 in the stir and repper section of the worksheet. So yeah, let's get started. Cool. Let's slowly build a bear from start to finish. Okay, first let's build the bear class for our basic bear. These bear instances should have an attribute name that holds the name of the bear and an attribute organs, an initially empty list of the bear's organs. The bear class should have an attribute bears, a list that stores the name of each bear. Okay, cool. So let's just run through the doc test just to make sure we have an understanding of this. So here we create the bear object, and when we try to access the name, it returns a string. When we try to access organs, it has an empty list. And the class variable bears returns a list of just the bears that we have created. And then we have another bear that we create called Winnie, and then as you can see, it also updates. Cool. So the first thing to do when you are writing a class is one of the things you could do is always start with um, defining the class variables. In this case, it is going to just be this bears attribute that we have. So we can initially just set that to be bears being an empty list. Nice. And so after that, we can go ahead and define the init method. This is going to be how we create our bear object as a reminder. And we have the first parameter be self. This is just going to be how we refer to an object as we go through the code. Hopefully that should be uh, okay to understand. But yes, so we have self. This is just the name that we use to refer to a specific instance of an object, an instance of a class. And we want to take in name and organ. Yes, organs. Cool. After that, we wait name attribute. I guess we don't need organs just because we're gonna set that. So we have self and name. Okay, cool. So now we can do self.name. This just sets the actual instance variable to be whatever we passed in. And then we do self dot organs equal to an empty list. And then after that, we want to add this to the bear class. So we access this bears class variable by calling the bear class and then the variable name, and then just appending the name of the bear, which is self dot name. And you could have also just done name itself. It's just yeah, we decided to just use self dot name since we've already defined it here. Okay, nice, and that's going to be 2A. The next step is going to be 2B, in which we have an organ class to put in our we want to build an organ class to put into our bear, and organ instances should have an attribute name that holds the name of the organ and an attribute bear that holds the bear it belongs to, and the organ class should also have an instance method called discard. This only has a self as a parameter, and that removes the organ from organ.organ count and the bear's organ list. So first thing to do is we want to just keep track of this. This is going to be the class variable. Bear and name are instance variables. And yes, we want to make sure that it edits both of these two things. It removes these underlines are chicken scratch, but hopefully you get the emphasis on what you should be looking for. And then the organ class should contain a dictionary organ count that maps the name of each bear to the number of organs it has. And as a hint, we may need to change the representation of this object for our doc tests to be correct. Now, if we go over the doc tests, we create these bears, we create an organ called liver, and if we try to call this class variable, it returns the name of the bear as a key and the number of organs that it has. Uh, keep going, we do the same thing. We check to see the instance variable of that bear, the organs instance variable of this specific bear, and it returns a list of just the name of the organs. As a little like hint, this is going to be where the hint comes in essentially. Just because if we were to do this with like the default repr function, this would have this weird like main and then like organ object or whatever, and that's not what we want. So yes, continuing on, we have this discard function being called by the liver itself, and that removes that subtracts one from the value of the key of the bear that we discarded from. So yes, and then we look at organs, that also gets updated. So yes, hopefully that should clear up some stuff. And now going into it, we want to define any class variables that we have. In this case, it would be organ. Okay, well, okay, it's either organ count or organ counts. We'll just do organ counts. So organ counts. This is going to be an empty dictionary. And then after this, we want to define how we want to create an organ object. So def init underscore, and then we have self. It takes in the name of the organ and the bear that it belongs to. And then we want to assign self.name. Yes, self.name to name. Sorry, self.name to name, and then self.bear to bear. And then after that, I guess the next easiest thing to do is to append this, instead of dealing with this first, we can just append the actual organ itself to the bear's instance variable organs. So we can do bear dot organs dot append, because it's a list, empty list so far. And then we want to just do, I think, self. Yes, self, because we want to do the object. Yes. Okay, next thing to do is we want to update organ counts, which is the dictionary. Uh, so what should we do? So when we are dealing with this dictionary, um, in general, we just want to see if the bear has been specified, and if it has, we want to add one to whatever organ count it has. But what happens if there is no bear that we see when we try to add this organs to the dictionary? It would error. So that means that kind of hints at like we have to have these conditions set up. So we want to set up an if else condition stuff, condition block, if else block. So we want to just basically see if the name, if name, you can also do if bear dot name for the sake of, oh, we want to make sure it is bear dot name and not just name itself, because the name in this case, in this context, is going to be referring to the organ. So we want to check if bear dot name is in. Yes, in. If bear dot name in organ counts, that means we have a key available for us to access, and we can just add one to whatever existing values there. So we access the organ counts object variable. Whoops, my bad. And then we want to access the bear name. And then we just want to add one. Nice. And then after that, else. This is if it is not in the dictionary yet. For this case, we just want to we want to create a key for it. And the way we do that is instead of just doing plus equals one, we just actually just set it to one because we have nothing to add to, so we have to just set it ourselves. Equals one. Nice. Okay. And yeah, that should clear it up for our init method. Now we have to do the repr function and the discard function. Um, I think we should do the repr function just because it's really quick. So we have def, repr, and then we just have self. So as I mentioned before, this would have the if we didn't override the repr function, it would have this weird main organ class thing. We don't want that. What we want is just the name of the organ itself. So we just want to return self.name. Nice. See, yeah, simple. Okay, now we have def uh, discard and then self. Okay, what does this do? I'm running out of room, but I think I have enough space. Okay, so what does this do? We uh, would be we would be affecting two things: the organ count and also the organs list, the bear's organs list. So what do? We, I think we're gonna assume here that there is a key that is uh, that. uh, no, actually, it is okay. We don't assume anything just because. Okay, never mind. Sorry, I forgot that we are like dealing with the organs themselves and not the bears. So we don't have to worry about like missing a key just because when we create an organ, it already establishes that it is in the diction. Yeah, okay, cool. Anyways, now we just want to do organ, not organ count to access what we already have. Then do counts or counts. Okay, cool. Organ counts, and then we want to access self dot bear, and then we just want to subtract one. Okay. Now after that, we just want to do the bears organ list. So we just do self dot bear dot organs dot remove and then self, and that should take care of it. And that is all of 2B. All right, moving on. Now we have 2C. We want to design a heart class that inherits from the organ class. And when a heart is created, if it's bear, does not already have a heart, it creates a heart attribute for that bear. If a bear already has a heart, uh, the old heart is discarded and replaced with a new one. The bear's organs list and organ.count. Organ.organ count should be updated appropriately. So kind of similar to what we had uh, for the parent class of this. And that kind of hints at like what we could do, I suppose. Yes, that kind of should like give you a hint of like how we should approach it. Uh, just like keep in mind like the whole inheritance thing and object-oriented programming makes it simple. Okay, so first thing we want to do is there is no class variables to uh, look at. So in that case, we can just go dive into the defining of the init method. And we see here that it's going to take in, that's going to do self, we'll do self first, and then it's going to take in the name and bear. Wow, kind of similar to the organ class. Okay, so after that, we want to just check. The main thing is here is that we want to use the has attribute to check if a bear has a heart attribute. I just realized I don't know if I read the hint, but the hint is there. We just have a function available to us. So that being said, looking at the docs task, let's see, trying to Okay, I think if we're just going to go with the dot test first, this kind of just shows us making a bear, and then this shows that if we do has Atcher on OSCI and pass in the heart, it's false. And when we do add it, and we do that, and when we do add a heart, uh, this is going to be how it's represented. That should be just be in the list, that's like before. Yes, okay. Okay, so just gonna check if a bear has a heart attribute. I think for all intensive purposes, uh, this isn't like comparing to see like if the heart. It's not checking to see if like I guess I guess okay. We are trying to see if Oski has a heart attribute, not necessarily like that heart has a heart with the name heart. So this is why like when we do big heart, it overrides it and like it goes true. Uh, like ideally. Okay, so if we were to start defining our thing, notice how it's like pretty similar to, um, sorry, wait, just gonna make sure I'm doing this right. Yeah, yeah. Okay, okay. Okay, notice how pretty much everything is the same from like the organ class, except we have this has Atcher, and then we want to make sure we want to make sure that it has an attribute. Okay, how do I? Okay, first things first. Everything is constant. A heart is a child of the organ class, so we can essentially just do like we'll fill in this block of code later, but right now we can just do organ or even super in the parentheses dot init. So name bear. Oh, yep. Okay, because everything's the same, that should be fine. Uh, yes. And back to what I was saying. Sorry, so many strings of thoughts just happened in that moment. Okay. We want to check to see if uh, the bear that we have right here does have a heart attribute to begin with. So we want to do if has Atcher, and then it then takes in the bear, and also heart. Yes. So like this heart right here is just going to refer to the actual instance variable of a bear object, as opposed to like the name of the heart. If that like clears up any confusion that you might have had. I know when I was doing this, I had that confusion. So, anyways, we want to check if it's we want to check this condition, and then if it is true, that means we want to just simply discard the bear.heart that was there. It's because that's what it tells us to do, and also we can use the discard method just because all the functions in a class's parent class is available to the child, unless it's been overwritten. That like it'll change. But yes, so we have that no else statement, and then we have bear dot heart equals the self. Yeah, and actually that's pretty much the entire code for 3C. And yeah, and like just to like reiterate the point that I was confused on, like this heart thing is referring to like this, if that makes sense. If that has the attribute, if bear has that heart attribute. Okay, cool. That was it for the entirety of two. So yeah, thanks.